Hey everyone! Today, I want to talk about the Runcam WifiLink2, a digital FPV system I picked up from AliExpress for just 78 bucks. It comes with a VTX, a USB network card as the receiver, and a dongle to connect your phone, so you can use your phone as the display. The VTX itself is only around 60 bucks, and that includes the camera. Just to put things in perspective, a regular analog VTX with a DVR is usually around 20 to 25 bucks, and a decent camera is also around 20 bucks. So for just a bit more, you can get a digital FPV system, which I'm super excited about. In this video, I'll do an unboxing and walk you through the setup. There are two versions you can choose from: the WifiLink2, which includes just the VTX, or the WifiLink2G. The G version also comes with a AC1200 USB network card and a Type-C dongle for connecting to your Android device. The network card has two antennas, but you can swap them out for your own high-gain antennas if you prefer. The dongle is slim with two ports, one USB for the network card and a Type-C port for charging your device. I've also got this 3D printed mount for the WifiLink2, which you can download from the Runcam WifiLink2 download page. It's designed really well, and we'll check that out in a bit. Let's dive in and open up the WifiLink2. When you get yours, the antennas aren't attached. I've already attached mine, but you'll need to unscrew the little screw and add them yourself. For port connections, you can refer to the user manual. Here's what comes in the box: a few screws for mounting the camera, an RJ45 to 4-pin cable, and a 6-pin cable to connect to your flight controller. The cables are long enough, so even if you mount it outside your plane, you should be good. I'm using the Speedybee F405 Wing mini flight controller, and you can connect the VTX directly to its DJI HD digital VTX connector. Next, I'll mount the WifiLink2 to the 3D printed mount. I use CA glue to attach the VTX mount body and the antenna's mount. There's a hole if you want to screw it on, but glue works just fine for me. Both sides of the mount are sloped to fit the cable ports, and on the right side, there's an opening for easy access to the SD card. On the bottom, there are some grooves. Looks like they're there to zip tie the VTX in place. It also has 4 holes where you can mount it with screws. The camera mount has 2 holes on the side. If you want more room to adjust the angle, you can use the top hole. For me, I'll go with the bottom one. It kind of limits the angle, but it keeps things nice and stable. I'll also use some zip ties to secure the antenna. Now, let's see what it looks like when connected to your phone. I don't have an Android phone powerful enough to run the Pixel Pilot software, so I'll use my Meta Quest 2 instead. If you want to set this up on your Meta Quest, there are plenty of YouTube tutorials that show you how to install APK files. I won't dive into that here. I'll put a link to the Pixel Pilot APK on GitHub in the description. When you open the app, go to Settings and set the channel to 161. That's the default for both the WifiLink2 firmware and the app, so it should work right out of the box. If your phone isn't showing anything, try using a different phone or connect to your PC to test it. The OSD uses MAV link telemetry, so you can go into the settings to choose which elements to show. You can also lock/unlock elements to make them selectable and movable. I couldn't get it to work with my iNav 8 firmware, but the iNav OSD with MSP DisplayPort is working fine, so I'm sticking with that. To configure the iNav HD OSD, go to the iNav port tab, change the peripheral on the VTX port. For me, it's URT5, and select MSP DisplayPort. Save it and reboot. Sometimes, you might need to disconnect both the USB cable and battery to get it to reboot. After that, head to the OSD tab, and for the format, I found that Avatar gives the most accurate resolution and the correct icon. If you use something else, it might cut off text or leave empty space. You can test and see what works best for you. Choose the OSD elements you want to display, then click Save, and you should have the iNav OSD up and running. Next, let's set it up on a PC. The WifiLink2 user manual makes it pretty straightforward. First, download the zip file from the link. Then click on Code, scroll down, and follow the steps under Usage. The user manual skips Step 3, which might cause the software to crash, so make sure you don't miss that. After opening the program, select the network card, set the channel and codec, and click Start to begin. Let's talk about the configuration file. Insert an empty SD card into the camera and power it on, and it'll automatically generate the config files. If you need to flash the firmware, refer to the manual. I'm using version WifiLink 2.8. In the config file, you can change the channel if you want to fly with someone else. I set the power to 55, lower the video resolution to 720p at 60 frames per second for longer range and quicker reconnection times. You can also set it to automatically record when you power it on. The recording will be at the resolution and frame rate you set, and it includes the OSD. When you power it back on, the file continues recording from where it left off. I'm having an issue that my PC needs to repair the SD card every time I reconnect it, which is a bit annoying. Also, if you have auto recording enabled and change the resolution or frame rate, the video file might get corrupted. The default protocol is exposed for you to choose MSP DisplayPort. I tried switching it to MAV-Link for the OSD on Pixel Pilot, and I couldn't get it to work. Honestly, I can't think of many downsides to this $60 digital VTX. It won't record high-quality footage, but that's not surprising for the price. If you don't have an Android headset like the Meta Quest, you won't get the immersive experience of goggles. Personally, I find using my phone way too small to see, so I prefer using goggles to land my plane, especially since I'm not the best at landing by just looking at the plane. So, goggles are a must for me. On the product detail page, it claims to have 28 dBm of power, which is about 600 milliwatts, I believe. However, in the user manual, it states 29 dBm of power, which is about 800 milliwatts. I'm not sure if that's a typo or something else. Anyway, it's not bad compared to many analog VTXs. Oh, and for now, it only works on Android and PC. Hopefully, they'll release an iOS app soon. In future videos, I'm thinking of doing a comparison with my DJI 03 in terms of goggle view, and a range test of the WifiLink2 with the original antenna and the high-gain antenna. If you want to see those, let me know in the comments. Before I wrap up, I want to show you how it looks on my 3D printed GRM airplane. I haven't flown it yet, but it has a huge fuselage and a canopy designed to hold the VTX outside the plane, helping to prevent overheating. The WifiLink2 already has a built-in fan, so it could go inside just fine, but I really like this mount design, so I want to give it a try. The mount is a bit big to fit on the canopy, probably because of the zip ties, but hey, it looks pretty cool, and I'll find a way to attach it on there. Alright, that's it for this video. Hope you enjoy, and I'll see you in the next one.